Okay, so in our last video we talked about how to describe continuous numerical data, so in terms of the center and the spread, and now it's time to talk about how to describe the shape of a data distribution. So the method for doing this is to use some of the graphs that I've already showed you here, which are frequency histograms. So if we just plot the data like I've shown you here on the left, where I've got everyone's weight here kind of in a single column, each person as a point, can't really tell what's going on with the data point. So instead, here's a histogram of that data. And so here's how we can do that in R. So we'll come down to a new line, comment our code. So all we need to do is use the hist function, and then this takes the argument anorexia $pre WT, and now I'm going to run this line of code, and it shows me a sad, boring gray plot. So I'm going to add a couple of additional optional arguments to this function that are just going to make this plot look a little bit nicer. And since Halloween's coming up, we're going to make it orange. So I want to divide the plot into more bins. So I'm going to use the breaks argument. And in this case, I'll set that to 15. And then I want to make it that nice orange color. So I'm going to use the call argument. And I'm just going to say orange here in quotation marks. Okay, so there's my anorexia plot. Okay, with a frequency histogram. Okay, and so now we want to think about the shape of this histogram overall. If your data are symmetrically distributed, so there's a kind of an even distribution to the left and to the right here, then your mean and your median will be similar to each other. So we saw that already for this data set. So both the mean and the median are going to be somewhere towards the middle. And this shape is kind of a classic shape for measurements for a wide range of types of traits. And so that, that shape that has that type of symmetry is referred to as a normal distribution. And this is also often referred to as a bell curve, right? So most of the measurements fall somewhere in the middle, and then there's some measurements that are smaller and some measurements that are larger, but an even distribution around that middle point. And as we talk about statistics, a lot of statistical tests will assume that data are symmetrical like this. But clearly from the other data set that I've showed you so far, not all data sets are normal. And I've got normal in quotation marks here because it is perfectly normal for data to be non-normal. So statistical normality is not the same as everyday use of the word. So not all data sets are normal. So here again is that population density data. And when the data have this type of asymmetrical distribution where we've got a lot of very small values and then just a small handful of very big values, the median is going to be a better representation of the center. And so these are kind of the two major types of distributions that we are likely to encounter in the wild. So this normal distribution and this asymmetrical distribution, or the statistical term that's used to describe this is a skewed distribution. So most of the values in one place, but then a small number of values very spread out from the majority of the values. And I'm going to show you a little trick with this skewed data, which is shown here. So in this case, if you have data that have that type of skew, and you take the log, your log base 10 of those values, you can actually get those data to look much more like that normal distribution. But that's a bonus trick. And I'm going to interrupt myself again here just because I want to really emphasize the point that it is completely normal to have a skewed distribution. And this again is where statisticians are using words a little bit differently than we use in everyday conversation. So talking about skewed data means something that's really specific, right? So it refers to that specific data distribution. It doesn't refer to messed up data. So keep that in mind when you think about talking about skewed data or skewed results. That means something very specific when you use that language. Okay, so that's a quick summary on how to describe the shape of data distributions. So we've got normal or skewed. And so up next, we'll talk more about how to describe the spread for data.